As the man said, my name is Darin Langone. I work for the Bloomberg company. I've been there about 25 years now. I've seen a lot of things, broke a lot of things, fixed a couple of things. Hopefully this goes well. My anniversary is in 2 weeks, so hopefully I make it. So what I'm about to talk about, and let me just get a show of hands. For the companies that you work for, do you have a dedicated team that does, let's say, pre- and post-testing for BIOS and firmware updates to ensure that there's no changes? All right, well, hopefully. Good to see some hands up there. But for those shaking their head, well, maybe there's some other people that should be in this talk. But anyway, the purpose of this is to provide a sketch of a framework that could be implemented and should be implemented by any company that has concerns regarding and maintaining the processing health and speed of their computational infrastructure. So let's start with some definitions first. I'm sure everyone knows what BIOS is, but we'll get back to that. Firmware. We've had a lot of new people in the company, and some people actually that don't know what firmware is. But anyway, firmware is specialized software that's embedded into hardware devices to provide low-level control of the devices. It provides the ability to fix bugs, add features, enhance performance, create bugs, and degrade performance. And BIOS, that's your basic input-output system, as you might remember from your textbooks. And these days, BIOS is relatively complex. You could set the amount of CPUs you want running on your server, set heat thresholds, fan thresholds, set performance thresholds. There's a whole bunch of things you could do. And you might see over time some of these things change. A lot of times a vendor might add a certain feature and it never makes it into the README. And suddenly your performance, you want maximum performance and maximum cooling, and suddenly your systems start overheating. And then you start looking around and realize, that BIOS certainly changed some things. Now, as I mentioned, vendors provide updates to firmware on a regular basis. These updates typically include new features, bug fixes, fixes for CVEs that have come out, the old common vulnerability and exposures that we've all been accustomed to, depending on your CPU manufacturer. Some are a lot worse than others. These updates are generally a welcome thing. Some of the features added are the result of customers asking for more functionality. Some are the result of customers complaining about problems that they've encountered. You really can't escape having to apply these enhancements these days. A lot of the vendors are sort of demanding in terms of your support for the devices, servers, and appliances that they go lockstep with certain updates, BIOS enhancements. They really are on top of their customers these days to apply these things. Where it used to be in the past, you just got your server, used it for a couple of years, and maybe you didn't do anything to the BIOS or firmware. Now, the values. So recently, we had this issue. We have this in-house system that goes around and checks the settings on our servers, and we use redfish calls, and we pull in all the BIOS settings. And suddenly, in the newer version of the BIOS on our test systems, the vendor changed the delimiters of just about all the fields. So we were used to parsing on dashes and things like that, and then they changed it to something else. So could you imagine rolling that into production? No, and it's not even in the README. You got to check, recheck, and have meetings with your vendors frequently, although they are surprised to hear some of these kind of things. Now, if you remember, when you first got some high-performing server, it did everything you needed in less time than it previously took, and everyone was happy. Then after some period of time, it didn't seem to behave the same. there are many reasons why this might have happened. Now, you started off with a really nice fast car. Look at that, it's doing 300 miles an hour in park. And it's not even any pressure in the turbo. Humming along at 7,500 RPM, pretty nice. And then you wind up with this thing. You know, everyone suddenly is disgusted. You know, they're like, we spent all of this money and look at what we got. But anyway, so over time, you've got to evaluate your servers for performance. You need to set up some kind of benchmarks in your enterprise environment. And chances are the teams responsible for a lot of the applications that might be running on this have a good idea of what the metrics are. So the best thing you could do is go establish a baseline. You know, it's best to just, I think of three things when I set this up. The overall health of the server, I/O, and the speed of your NVMEs. I think that's the three basic things, and then you throw in a smattering of things that matter to your application groups, you know, database latencies, calls, different types of system calls, all of those kind of things. And I'm not advocating for one benchmark over the other. There's no secret sauce. It's just up to you to find out what it is that works best for your company. But just looking at those three kinds of things will probably give you a good idea of looking and finding for performance changes over time. And it's not just over time from version to version. There's the cumulative effect too. And we'll look at that shortly. Now, why should we test? The vendors are not looking out for our best interest. As I mentioned, you probably already have valuable metrics regarding your application's network operating system performance. When the firmware is developed and released, there's a high probability that the negative performance changes that you might see and what you're measuring could be not just the issue with an application where it might actually be detected first, but it could be the result of firmware or BIOS changes that the vendor's rolling in to fix a known issue. They're really just testing for functionality, see if it works. They're not doing any pre or post-test performance analysis. And consider the idea of performance over time. Now, you start off with version A and move to version B. There might not be a significant difference in performance, maybe 1.5%. For me, when I look at before accepting something is I tend to hover around the 3% mark. 5%, in my experience, has been way noticeable. But for something sort of innocuous, I think 3% is probably the level of significance. You know, your mileage might vary. But in going from version A to B, you might see a degradation of 1.5%. It's not considered significant, and it might not be much of a concern. But some bugs you'll never encounter got fixed because you're not using certain aspects of a current device. A few months later, a new fix comes out, version C. This might cause a decrease of 1%. So, you know, you compare it to the previous one, nobody really cares, you roll it out. A few months go by, now you got version D, and we drop another 1.5%. You compare it to the previous version, you only see that 1.5% change, but in essence, from the baseline, we're actually down 3.5 to 4% at this point. And a great deal of the clients, you know, your client machines are updating, they're getting all of these fixes, and suddenly, you know, application developers, clients, customers might start seeing issues. Because now at that level, suddenly there's a noticeable change, and from version to version, it didn't seem significant, but yeah, it happened. So now in your testing environment, you should have servers that totally mimic what's in your development environment. There's really no exceptions for that. You need to run in that environment exactly what you're running and try to mimic as much as possible of how it's running in production. And focus on I/O-based benchmark tests, CPU-based benchmark tests, memory tests, and overall I/O, CPU, and memory tests. And then, as I mentioned, develop a few tests based upon your own applications. We use a lot of databases. We have custom databases. So for me to get something to run metrics, it's pretty easy. I just sit down with the developer, ask them what is important to them, and they'll just fire off some test that I could use. And then I'll take the results and I'll put them into some graphical representation. It'll get stored in a database. The database doesn't get pruned or anything because we might have to go back maybe years, and compare the way it's running now to the way when we first got it. So it's great to have that, throw it on a database back end or something and just have all your graphs showing up and make it easily accessible by the developers, management, whoever really needs to see that data. Now how? So I was just talking about getting everything into an observability platform. So always have a pre-test, compare it to your post-test, and then compare all the data sets over time. We don't need like crazy statistics, just measures of central tendency. What was the average last time? What's it now? What's the difference? Those kinds of things, just to get those percentage changes and have some reporting on the results. Now, here's an example. Firmware comes out to fix a security vulnerability. You load it on your benchmark systems, you make sure that you have your pre-test data, and what this... Got a little ahead of myself. So load it on your system, look at the completion times. And here's what we got. We got a graph of our real-time behavior from some set of database calls. As you see, as the versions go on, we're actually getting a little better, which is pleasant to see. Doesn't always happen that way, but that was a example we got when we work closely with our hardware vendors and really push them and let them know that we can't have degradations in performance. And a lot of the secrets that we deal with is like, one thing is we use a lot of just commodity hardware, or at least components, and then we get the vendors to create specific, or at least in some circumstances, specific firmware for our components, and then we track them, and then with input from the application groups, we go back to the vendor in our regular meetings and asks for specific tweaks. So now here's something kind of interesting that illustrates what I was just talking about. So you get some new firmware or BIOS, and as time goes by, we get to version 4, we're down 2%. Version 5, another 2%. 6 and 7 don't show any difference. Then we're down another 2%. And then we're fine for a while, and we actually get a little performance increase of 1%. But if you're not paying attention to these things, you might think that, between my last version and this version, we're only down 1%. But looking at the accumulation of the degradation, you're actually down 5%. And here's another real frightening thing. When rolling in CVEs on BIOS, you really got to test, because there's some CPU manufacturers that seem to do things, or at least they mention, but they don't do anything. And you'll wind up, with over a 10% difference, and everyone's wondering why things don't function. or he was one of my favorites. Working with the vendor, everything's fine. We got some good numbers. Suddenly, they provide version 11, and you don't want to be the guy that rolled that one in. You're going to have a lot of conversations with a lot of people above your pay grade. Now, to avoid false positives and bad results, know what your data is. Know the look and feel of the graphs that you typically get. You know, like I was working with somebody, they're like, oh, this looks really bad. You know, we went through the logs, the database was doing some cleanup, and that's why the beginning of that graph is so depressed. Know when to stop. I don't know about you, but I love doing this stuff. I could do it all day long, and sometimes I just go crazy. And my manager's like, stop, looking into all of these things. But you just focus on your task, provide the results, be totally objective, and that's probably the best that you could do. That's where I'm at. The questions time. Thanks.